Hi everyone, this is Mrs. V Chan. Welcome to my Form 2 Math lesson number 11, and today is 23rd March 2020. Alright, so today's lesson is about Pythagoras theorem. And then who is Pythagoras actually? So he was a Greek mathematician, and he stated a theorem relating to the three sides of a right-angled triangle. So here we have a right-angled triangle, and this theorem was named after him as Pythagoras theorem. All right, so in this right-angled triangle, so we have three sides, so that is A and B and C. All right, and then we name this C, which is the longest side, all right, in a right-angled triangle as hypotenuse. Okay, so therefore, if angle ACB is 90 degrees, so this is 90 degrees, so this is a right-angled triangle, and Pythagoras stated that A squared plus B squared is always equal to C squared. Okay, and the reference is PYTH dots stand for Pythagoras theorem. Okay, which stating the relationship of three sides of this right-angled triangle. Okay, let's do some exercise. So here we have example 1, find the unknown. Okay, so once again, this is a right-angled triangle. So here is the right angle, and the one opposite to right angle P is the longest side. So what is the longest side? We call that hypotenuse. Okay, so therefore we can use Pythagoras theorem to link these three sides up. That is, P squared, the longest side, is equal to this, right? And the reference is PYTH dot theorem. Okay, so here we have P squared. So to work out P, we need to take square roots on the right hand side. Now let me calculate what do we have inside the square roots. So 8 squared and then plus 5 squared. So therefore I have 89 inside the square roots. Okay, now since we have to express our answer correct to three significant figure, so that what is square root of 89? So square root here. Okay, so therefore the answer will be 9.43, so which is three significant figure. All right. Okay, so again we have another right-angled triangle here, and Y is the unknown. Okay, so remember this is right angle, the one next to right angle, so 17 here is always the longest side. So what do we call the longest side? Which is hypotenuse. Okay, so therefore we can use Pythagoras theorem, so which is y squared plus 8 squared, always the same as 17 square. Again, what is the reference? PYTH dots and theorem. Okay, so this is a new thing in this chapter, Pythagoras theorem. Okay, so next I have to find y by solving the equation. So this is my subject, and then I move this to the right hand side, minus 8 squared. All right, so next to find y, I need to take square roots. So therefore I have 17 squared minus 8 squared. So therefore I have 2 to 5 inside. Okay, so what is 2 to 5 square roots? So which is 15. So this is how we find the unknown by using Pythagoras theorem. Okay, now example 2. We have another right-angled triangle. So again, which one is hypotenuse? So EF here will be hypotenuse. So HYPOTENUSE. All right, so this is the question given to us. So given EF, so this is EF, is 3DF. Okay, and now we need to find the length of DF. Correct answer to three significant figure. Okay, next to find DF, I need to go back to the relationship of this EF is equal to 3DF. So which one is the smaller one? So DF is the smaller one. We always let X be the smaller one. So therefore EF will be 3X. Okay, so after that, I can use Pythagoras theorem to link them up. So therefore, I have this side. So df square plus DE square. DE square is equal to the longer side, which is EF square, and that is Pyth dot theorem. So we have this Pythagoras theorem. Okay. Okay, so therefore I have this df is x, so this will be 3x, right? And now I do substitution. Df square is x square plus de square is 6 square, and then equals to 3x all square. All right, now this is important. The bracket is very, very important here. Okay, so why the bracket is very important? Because 3x squared is not the same as 3x all square. Okay, this is very, very important. So therefore, what do I have on the right hand side of the equation? I have 9x squared. So you can see 3x squared without bracket here is not the same here. So this bracket is very, very important. Okay, so that would be x squared plus 6 squared. Right, okay, since I have this side is bigger, so that I can exchange the position in this way. Okay, therefore I can move this x squared to the left hand side, so 9x squared minus x squared, so that I have 8x squared, which is equal to 36. Okay, so what is x squared? X squared will be 36 over 8. So don't worry about this. Okay, I just use calculator to work out the final answer. So this is x squared, so to work out x, I just take square roots for this 36 over 8. Okay, and now I can use calculator. Okay, now I use calculator to work out x, so here is square root, and then I have 36. So this is a fraction, so here is fraction, so 8, and get your answer. So therefore, the answer is 2.12 cm. Okay, so this is how we find df, and df is equal to x. So, and here is x, so you can write your answer statement and saying that df is equal to 2.12 cm. Okay, so next we have this triangle. However, there are two triangles. So this is a right angle triangle, but however, this PRS is not right angle triangle. All right, so that we cannot use Pythagoras theorem in this triangle PRS, because we can only use Pythagoras theorem for a right angled triangle. All right, so here is the condition. Find the length of RS. So this is RS that we don't know, and then correct to 3 significance figure. Okay, so therefore I start with the big triangle. So here is in triangle PQS. So PQS, the big one, and which is also a right angled triangle. And obviously 13 is the hypotenuse. So therefore I can use Pythagoras theorem. So saying that, so QS square plus 6 square is equal to 13 square, and this is Pyth dot theorem, Pythagoras theorem. Okay, all right. Okay, and after that I have my QS, and then I can take square roots. All right, so therefore I have 13 square minus 6 square. Okay, so QS is not the final answer because we need to find RS. So at this stage, we don't work out the exact answer. So we leave everything in short form. So we don't round off yet. Otherwise, the final answer will not be correct. So that would be 13 square minus 6 square is 36. So I have 133. Okay, square roots. Okay, leave this answer and work out that later. Okay, so next we look at this smaller one, smaller right angle, the triangle, so that here in triangle PQR, and 8 is the hypotenuse, so I have my hypotenuse here, and then QR is here, so QR square plus x square is equal to 8 square. So again, this is Pythagoras theorem, and now I need to find QR, change subject to QR, okay, by taking the square roots, so which is okay, so 64 minus 36. And similarly, don't work out the exact answer yet at this stage. Okay, so that will be, I have 28 inside the square roots for QR, right? Okay, now finally, I have enough information to work out RS because RS is equal to this one, the longest one, QS minus QR. And now I can do substitution. So what is QS? QS is roots 133 and then minus root 28. And now I can use calculator to work out the final solution. Okay, and then how do we use calculator to work out the final solution? So here I have roots 133 and then get your answer first and then minus root 28. Okay, so this is the answer for RS, so which is 6.24. Okay, so one more thing to remind you, Pythagoras theorem only applied to right-angled triangle. All right, if it is not right-angled triangle, we can't use Pythagoras theorem. Okay, example 3 here, we need to find the area of ABCD. So this is ABCD with right angle here, right angle here. So that means AB must be parallel to DC. So that this is also a trapezium. So trapezium, right? Okay, and what is the formula to find area of trapezium? So therefore we have the upper side, which is AB, plus the lower side, DC, times the height, which is AD, and then divided by 2. So we know this AB, the upper 6, and the 9, we know this. And what about AD, the height? We don't know the height, so therefore we have to find AD. Okay. Alright, so to find AD, which is also the height of the trapezium, I need to add this line, which is BE, and also perpendicular to this line. So that add BE, which is perpendicular to DC. So therefore, you can see I have a right-angled triangle here. Is that right? So that I can link these three sides up by using Pythagoras theorem. So this is 9 cm, this is 6 cm. So that what is EC? So that I have my EC is equal to 9 cm minus 6 cm, which is equal to 3 cm. Okay, so therefore I can use Pythagoras theorem whenever there is a right angle triangle. So here, this is right angle triangle. So this is BE square is plus 3 square is equal to 5 square. So this is again Pythagoras theorem. Okay, now I can solve equation to find the subject here. So that would be 5 square minus 3 square. Now I take square roots. So since BE is not the final answer yet, so you don't need to work out the exact solution for BE. Just leave everything in surd form. So that would be 25. Oops. That would be 25 minus 9. So I have 16. Oh, 16 square root, which is 4. All right. Okay, now I have enough information to find the area of the trapezium. So what is AB? AB is 6 plus DC is 9. Okay, so times AD is the height, which is 4 divided by 2. And then you just use your calculator and the area of trapezium is 30 cm squared. Okay. Okay, so here we have the final example and then we will finish this chapter. So this is find the perimeter of triangle ACE. So where is ACE? ACE. Okay, so since we need to find the perimeter, so the perimeter of that will be, okay, 3 sides, right? So that will be the sum of AE plus EC and then plus AC. Okay, so therefore to work out the perimeter here, I need to go back to the relationship. This AE is equal to this. Let's do some revision on ratio. So therefore I have AE is equal to 3 over 4 and then ED, right? And then I move this 4 to the left hand side. So I have 4 AE is equal to 3 ED. Okay, I want to know the ratio for this. So I change this to fraction. Okay, so 4AE, so do cross multiplication. When we have that, we have 4 here and then 3 on top. So therefore, I can work out the ratio for AE to ED, which is equal to 3 to 4. Okay, so after I get the ratio for AE to ED, which is equal to 3 to 4, and then now I can use K to link them up. which is AE is 3K, ED is 4K. So here is 3K and this is 4K. So at the same time, this 3K plus 4K is equal to 7. So I can solve K by doing this. 3K plus 4K is equal to 7 cm. So 7K is equal to 7. Therefore, K is equal to 1. Okay, so therefore, what is AE? AE here is same as 3 cm. Okay, and ED here is same as 4 cm. Okay, so after that, I can go back to my perimeter. Now AE, so this is AE. AE is 3 cm, so I put 3 here, plus, what is EC? So this is EC. Okay, therefore, I need to look at another right-angled triangle here, right? And DC is 24 as well. Okay, and this is 4 cm. Okay, so I can use a separate step to find EC. Okay, so here is the step for EC. So we need to refer to this right-angled triangle. So therefore, we have this EC square, which is the hypotenuse, which is equal to 4 square plus 24 square. Of course, this is Pythagoras theorem. So how do we find EC? Again, we take square roots. So what do we have inside? So that will be 24 square plus 16. Okay, so therefore, which is 592. Okay, no need to work out the exact answer at this stage. Okay, take that in square roots to work out the final answer later. Okay, so finally, we need to find the length of AC. So to find AC, we need to look at this triangle, which is triangle ABC. So AC here is the hypotenuse. So we have AC square is the sum of 24 square plus 7 square. Again, to find AC, take square root. So that will be 24 square plus 7 square, which is 49. So I have 625. Okay, since 625 is a nice figure, so I can get a nice figure for that, which is 25. Right? Okay, so AC is 25. All right. Okay, so finally, we can use calculator to work out the final answer. So here is 3 plus square root 592. Get your answer first, and then plus 25. So 52.3 is the final answer for the answer of the perimeter in this diagram. Okay, so that's all about Pythagoras theorem. So thank you for watching my video. I'll see you next time. Bye bye.